Try, adapt, learn. In this video, we're going to rewire and grease the gears in our Singer sewing machine project. If you haven't already subscribed now for more videos including DIY, maintenance, and projects. As seen in our previous videos, our project machine is a Singer sewing machine model 15 or 1591. After restarting the lubrication process by soaking the parts with sewing machine oil, the machine was left to dry for about a week. Although we have got the needle assembly to move up and down, it still had issues sustaining the movement. To help with this issue and safety concerns, we're going to rewire the machine. To provide some context, I have made a wiring diagram with my best interpretation of the electrical circuit for this machine. With that in mind, this diagram may not be completely accurate with the symbols chosen. This also means that this is not a how-to video, but more of a how I did it. To begin this process, we will start rewiring the connector for the power outlet and the motor controller, also known as the foot pedal. I am marking the wire to the outlet with blue tape. As seen, many parts of this machine may be assembled and disassembled with different sizes of flathead screwdrivers. Although I have moved the tape further down, in this view the line from the outlet is at the bottom. The insulation on the line from the outlet looks darker black. I loosened these wires, but if you create your own diagram, you can just cut them out. This type of plug is known as non-polarized. It also has two identical connectors, which means it has no ground terminal. The identical connectors also mean that the plug could have been inserted in two different orientations for the hot and neutral wires on the outlet. This is the plate at the bottom of the motor controller, also known as the foot pedal. We will open the motor controller by removing the screws with the flathead screwdriver. Once the motor controller is open, you can see and access most of the parts inside the assembly. This is a simple demonstration of what happens when the button for the motor controller is pressed. A plastic brush was used to quickly clean some of the surface. With the motor controller open, the wires can easily be removed with a flathead screwdriver. We will use a new cord that is also connected to a two-prong connector. Although this connector is polarized, it shouldn't matter since the previous connector was non-polarized. We will mark one of the cords with blue tape to indicate the wire for the power outlet. This wire is 16 gauge and rated for 300 volts. And although it only has one layer of insulation, I chose to use this style because it can easily be split. Splitting the wires makes stripping the insulation from the conductor wire very simple. Once the insulation was stripped, the stranded conductor wire was exposed. These wires are twisted together and share a common connector as seen on the original wiring. The heat shrink tubing was then placed over the insulator, followed by a new ring terminal connector. The ring connector was then crimped onto the conductor wire using a crimp tool. Solder was then added to help fill the gap between the wire and the ring connector. Solder was also added to the wires that were previously twisted together. Heat shrink tubing was then placed over the insulation of the two wires. A heat gun was then used to apply heat and shrink the tubing. This was the plate at the bottom of the motor controller. We turned over the motor controller and some of the tips of the nails and screws were exposed. Although another surface was and should be glued to the bottom of this piece, for now we will grind these tips. When reinstalling the new wires, we will also include lock washers. This will help to add space since the mounting surface of the terminal is not flat. With the new wires in place, the cover can be reinstalled on the motor controller. The screws were then tightened. The motor controller was then pushed back into place on the mounting bracket of the base plate. The loose material was then cut from the sides of the base plate. The new wires were then pushed through the hole of the plastic connector. Instead of how I did it for this video, for maximum clearance, this can be done immediately after cutting the wire. The conductor wires were then wrapped around the terminals. This took a little while considering the size of the insulation and that it would have to fit between the split case of the connector. Once the wires were in place, the terminals were tightened using an adjustable wrench and pliers. With the wires tight in the terminals, they were then pushed into the plastic connector. Once inside, the second half of the connector can be set in place with fasteners. Plastic zip ties were used to help hold the wires in place near the connector. Quick test with the machine showed a big improvement with the new wires to the outlet and motor controller. The next stage of rewiring would be the wires to the light bulb and the motor. We started this next stage by removing the electrical connector with terminals that are attached to the machine. As seen, these wires were held to the terminals with thumb screws. The wires didn't have much visible cracking, likely because they remained in position. However, if they were bent, the insulation would crack. We then began to strip the insulation off and cut new wires. The insulation was then stripped and conductor wire exposed. The wires were then set up and heat shrink tubing was then set in place. The ring connectors were then set and crimped on the conductor wire. Once the wires were crimped, solder was added to the space between the conductor wire and the ring terminal. A heat gun was again used to apply heat and shrink the tubing. Next, the old wire from the connector to the light was removed. When removing the last thumb screw, the connector fell free and the wires to the motor remained. The new wires were then set in place with the ring terminals, washers, and thumb screws. The light bulb assembly was taken apart as if the light bulb was going to be replaced. As seen, this is a 120 volt 15 watt light bulb. While looking, you'll notice the bulb for this machine has no threads. Instead, it has two small prongs that hold it into place. The light bulb assembly was removed with two screws facing toward the bottom. The metal brackets on the side of the light bulb assembly were removed. I used snap ring pliers and a magnet to remove the first ring. This was unnecessary. This is because with the metal brackets removed, a flathead screwdriver can be used to remove those big rings. The gap was too small on the last ring, so I chose to cut it. Now the problem with cutting it is that I also cut the plastic case. So after trying a long time with several tools, I ended up using a cutting wheel. The problem with the cutting wheel is that it cut the gap far too wide. I then pried the ring off with a flathead screwdriver. Now although the ring was cut too wide, I still wanted to grind the ends down flat. With the light bulb assembly, I removed the old wires by heating up the old solder with a soldering iron. I inserted the new conductor wire in the hole and twisted the wire around the connector. I then wrapped the second wire around the second connector and soldered it. Both of the connectors with the new wires were then reinserted into the light bulb assembly. The new wires would be a tight fit in the assembly because of the size of the insulator. So I used an X-Acto knife to cut the insulator. As seen, a lot of damage was done to the case, so this is definitely not the way to remove and reinstall the ring. I used the flathead screwdriver to help reinstall the larger rings. This of course went much easier and I pushed the brackets back into place. With the brackets back into place, I screwed the light bulb assembly to mount it on the machine. I reinstalled the light bulb and the parts surrounding it. I quickly tested the bulb before moving on. I used the flathead screwdriver to remove the stop motion screw off of the balance wheel. This piece fell down quickly. As installed, the 3 straight bumps are facing into the balance wheel as indicated by the wear marks on the balance wheel. Now if you turn it over, you can see 3 bumps that are circle shaped. There's also 1 circle cut into the balance wheel. So I think I will try to install this piece with the circle bump faced into the circle hole. The balance wheel was then removed from the machine. As seen, there is a ring gear attached to the balance wheel. In line with the shaft connected to the motor was a worm gear to drive the ring gear on the balance wheel. In this view, we have good access to grease the worm gear and ring gear of the balance wheel. We're going to remove the screws to free this assembly because we are rewiring the motor. As seen with the 2 screws out, the case housing the motor assembly can be removed. Here's another view with the ring gear and the worm gear. Next, we remove the 2 screws holding the cover for the electric motor. As seen, the motor is able to turn freely. In this view is the label for the motor. Next, we remove the 2 screws in front of the motor. These 2 screws help to hold the motor assembly in place. The motor may also be held in by a grommet for the electrical wire. This grommet was so brittle it crumbled out of place. I then used a flathead screwdriver to help free the motor assembly. I also removed a screw at the end of the motor case. However, this didn't seem like it was holding the motor shaft in place. Next, I removed the first screw holding the worm gear in place. I then removed 2 smaller screws holding the motor shaft in place. I removed the second screw holding the worm gear in place. With those 4 screws and the worm gear out, the motor and shaft were then free to be removed. I then quickly wiped the parts with a dry shop towel and brushed them with a plastic brush. To get an idea about the condition of the wiring from the motor to the connector, this is what happens when it's bent. I placed the grommet over the new wire. For reference, the hole for this wire measures about 10.88 millimeters or 0.4285 inches. This grommet being used is 3/8 of an inch or 9.5 millimeters. The grommet was not near the right size, but it was new and would have to work for now. I used the small flathead screwdriver to help push the grommet in the hole. Please keep in mind that this is not the proper size grommet for this hole. I cut wires from the motor to the connector. I then used the long-nosed pliers to show how brittle the insulation was on the old wire. I split and pulled the new wire apart. I stripped the insulation off of the new wire. In this view, I'm wiping the inside of the motor case with a dry shop towel. The inside of this case is almost fully enclosed with carbon brushes for the motor. So this means that what I'm wiping off is most likely carbon deposits as the motor brushes wore down. As seen in this view, I'm going to keep the internal wiring for the motor intact. I'm choosing this because the wire is able to bend without the insulation breaking. I also do not have wiring with the same material for insulation to replace them. I then set the heat shrink tubing in place. Then I took the wires and wound them together. I soldered the wires using a soldering iron. I moved the heat shrink tubing into place. I again used a heat gun to shrink the tubing. With the wiring done, I started to wipe off the old grease with a dry shop towel. I started to wipe off the worm gear with a shop towel and plastic brush. I cleaned the worm gear with a shop towel and plastic brush. I then started to wipe the old grease off the ring gear and balance wheel. The proper cleaning procedure would include a full disassembly and using some kind of chemical solvent. This grease seen here was hard on the surface. Although it is improper and easier to score the surface, I chose to use the pick tool because it was easier to remove the hard grease quickly. These screws would be facing the bottom of the machine. The screws lead to cylinders that allow the operator to grease the machine. The packed grease in these cylinders will lubricate the worm gear and in turn the ring gear and balance wheel. As seen, I used the pick tool to remove the old grease. With most of the old grease removed, I wanted to reinsert the motor shaft and worm gear. Using the pick tool on the screw hole helped to hold the worm gear while the motor shaft dropped into place. As seen, I'm using pick tools to hold the carbon brushes in place. This is unnecessary if you remove the motor cap screws that are holding the springs for those carbon brushes. However, these screws are plastic, and the reason why I did not remove them is one of them was broken at the time I was recording. And although the pick tools were able to hold the carbon brushes in place, new plastic cap screws will need to be ordered. While putting the motor assembly back together, it took a little while to tuck the wires in. Because this machine does not have a ground wire, it is extremely important that the insulation is in good condition for this motor assembly. If the insulation was cracked and a live wire were then to touch the chassis of the machine, it could then create a risk of ground fault and electrical shock if the operator would touch the machine. Here's a quick check to make sure the motor spun freely. When restarting screws to the motor assembly, it was easier to begin with a little gap to see where the threads meet. With the motor and shaft in place, it was time to add more new grease. Unlike Singer sewing machine oil, which is clear Singer lubricant, this is white colored out of the tube. This lubricant may be the same color as white lithium grease, but it seems a lot more tacky. It also looks different from the old grease, but that's a bad comparison because the old grease could have been in the machine for over 66 years. The cover was then screwed back onto the motor to prevent extra grease from getting inside. In addition to the worm gear, the surface that the balance wheel would be set in was also greased. I then filled the maintenance holes as much as possible with new grease. Keep in mind that these were packed with old grease, and once the worm gear spins, it would immediately draw in the new grease from this location. I stopped when most of the tube was done and I could see the grease had reached to the bottom of the worm gear. Grease was also added to the surface where the motor case would meet the sewing machine. Since this part is not moving, it's more for corrosion protection. The two screws that hold the motor case to the sewing machine were then reinstalled. The screw at the end of the motor shaft was then reinstalled. Grease was then added to lubricate the ring gear and the balance wheel. Again, this is the orientation that the piece was installed previously, but I'm going to flip this over. I want to try to put the circle bump into the circle cut hole. I then double check the thumb screws for the electrical terminals. After checking, the electrical connector was then installed back into the sewing machine case. So in addition to previously lubricating with sewing machine oil, it was time to test the sewing machine with new wiring and new grease. And as seen, the sewing machine appears to be operating smoothly. Much more smoothly than it was first acquired. As I make new videos, I want to share them with you, so subscribe now. Also comment, like, and check out some of the other content on our channel.